Hello ladies and gentlemen, welcome back. This is a video tutorial for students who are in Geometry Goal 3. We are now getting into Ms. Dubois' favorite part of the chapter, which is congruence and proofs. And to the point where this is part 1 of the family. You can see there are a couple of topics I don't have highlighted because I just physically ran out of room, and I'm worried about how long this video is going to be to begin with. So good luck future me. So having said that, let's get used to everything first. Congruence, again, equal sign with a squiggle over it. There are different ways you can prove triangles are congruent. And then proofs, we remember from earlier chapters, this is going to come in 2 flavors, which is introduction and then completing. I generally, as a rule of thumb, I believe the one I want is completing first, and then intro you want to do second, even though that visually, just in terms of wording, is a little bit awkward. But before we get even there, let's get you used to the different types of triangle congruence first. So, scrolling down, let's see here. It was a little bit, can I get this all on one screen? There we go. Okay, so again, because I'm doing screen grabs instead of interacting with the software, I can't actually show you, but what you're doing is you're just going to be taking this, moving it around, and then making it match up with the other triangle. And then all this is, when you're dealing with congruent triangles, is this is a matching game. Matching game. And that actually makes this a lot easier. So if you're looking at side DE, DE is this side. Which is my matching side over here? ST, the side of ST. EF, EF is my little short side. What does it match? It matches side RS. What about DF? DF is the very long side. It corresponds, there's your keyword again, corresponds and matches side RT. That's what you're doing here. Complete the congruent statement. So angle D, my tiny little angle, what does it match? Angle T. Angle E, which is my big angle, what does it match? Angle S. Angle F, that's my middle angle, what does it match? Angle R. So this one is always going to be the same answer every time, yes, and the triangle is congruent. I'm only going through one example of this because the matching game makes this pitifully simple. I'm also similarly going to be going through only one iteration of this topic because it's the same idea. All you're doing is you're taking these sides and you're manipulating them in a way so that they match, and then you have your congruent triangle. And then the question is, are the 2 triangles congruent? Yes. And then you have your drop down of what your choices are. So what I really want to do with this topic is talk about my choices. You have side, side, side. That's how you read that as side, side. So, okay, let me actually start a little bit earlier. When you're looking at these, you have S, which stands for side. You have A, which stands for angle. Those are the things. So if you have side, 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 what that means is all sides are congruent. So this side matches this side matches this side matches this side. That's what they mean. If you have side, let me draw a picture of that actually. I'll do that even one better. So that means beep, 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 beep. Okay, next up, side, angle, side. That means you have an angle between 2 sides. Writing it in words is always a little bit awkward. Basically, the picture is going to be you have a side, you have an angle, and you have a side. So long as that angle is between the 2, then you have side, angle, side. Next up is the reverse of that, angle, side, angle. So that's a side between 2 angles. And again, picture worth 1,000 words. You have an angle, you have a side, you have an angle. So long as the side is between the 2 angles. Next one is angle, angle, side. So that means, this one's a little bit hard for some kids to see. What that means is you have 2 random angles and then a schmuck side that's nowhere near the other 2, okay? Those are your 1, 2, 3, 4 major sources of congruency. Side, side, angle does not exist, and you know that because somebody somewhere inevitably is going to be immature, reverse the letters, and realize why it's bad. So, moving on. Looking over here, since I have all of my pictures done up on the side here, I have an angle, and I have a side. And is the side between or is it outside? It's outside, so therefore, yes, the 2 triangles are congruent. Oops, dotted the wrong thing. Yes, the two triangles are congruent, and that's because this is angle, angle, side, and this one would have been side, side, side. That's what you're looking to be doing for these two topics. I'm even going to hit myself on pause for a second so you can get these 4 pictures and theorems written down in your notes. Okay, hopefully you're done pausing and you have this in your notebook. Now let's actually get used to this. So we're identifying and naming congruent triangles. We're identifying and naming congruent triangles. So we know that these two are congruent, and we know since it's a side and a side and a side, this is the side, side, side property. The question now is a matching game. Since this is a matching game again, this is a letter G. So what does G match? G is between the 1 tick mark and the 2 tick marks. Which letter is between 1 and 2? J. So this is going to be triangle J. And then it's H. H is between the 2 and 3. What's between the 2 and 3? K. And then finally, your leftover letter is L. That's what you're looking to do. Again, I say it again. I'll say it as many times as necessary. This is a matching game. All you're doing is making the matching letters line up in the same way. This one, let's see here. We have a side and a side, but that's all we have. You always need 3 things to prove congruency. If you looked over here, it was angle, angle, side, 1, 2, 3. Angle, side, angle, 1, 2, 3. Side, angle, side, 1, 2, 3. Side, 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 1, 2, 3. We only have 2 things over here. We have one side and then we have the other side. We don't know anything about any kind of angle or side, so this is not necessarily congruent. Over here, we have 2 angles and a side, so it's going to be either angle, side, angle, or angle, angle, side. The question is, where does the side fall? Is it between? No, it's not. So this is by angle, angle, side, and now we play matching. A is the double arced angle, which corresponds to triangle D, and then B is the one without a mark, so D, E, and then your leftover letter is F. That's all you're doing. Again, we have an angle, we have a side, but we don't have a third piece of information, so this is not necessarily congruent. This is very obviously side, 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 so M is where? M is there. It's between the 1 and the 2, between the 1 and the 2, so it matches triangle Q, and then N is between 2 and 3, 2 and 3, Q, P, R. And then this one, we have 3 pieces of information, which means it is congruent. U matches, that's the 1 arc mark, so it matches triangle Y. And then V matches the double arc mark, which is X, Z, Y, X, Z. And which one is it? Is the side outside or between? It's outside, so this is angle, angle, side. Okay, now we get to the proofs, which is what Ms. Dubois just smiles over. Love it. And again, I will say this in every video if I need to. This will be hard unless you label everything. The reason why Ms. Dubois is going to be able to go through this as fast as she does is because I can write on all of these diagrams. For students, I cannot say this enough times. You absolutely must copy down your diagrams and label everything that you're given, or else you are going to go out of your mind. So, first things first. We always start with our givens. So we're told that EF is congruent to GF. We're told that DF is, double tick mark Ms. Dubois, is congruent to HF. That's what we're told. So DF is congruent to HF because that's given. EF and GF is because that is given. So those are the 2 easy ones. Next, we don't know necessarily what we're supposed to do. Like, we have 2 sides, but what else? But they give a hint away. You have DFE. DFE is congruent to angle HFG. HFG. Hey, what kind of angles are those? Those are vertical angles, and vertical angles are always congruent. Next up, what kind of picture do we have? Side, angle, side. Okay. In my college days, Ms. Dubois' college days, we used to actually have this called the bow tie theorem because it makes a little bow tie, but that's Ms. Dubois being a nerd. Okay, what are we told? We are told EF is congruent to GF. EF is congruent to GF. Okay, I forgot my little segment bar. And then what are we told? We're told that DE is congruent to DG. Okay, and that's because it is given. So far, so good. And next, we're told DF is congruent to GF. DF is congruent to DG. DG is congruent to DF. And I'm going to do my little bit different. I'm going to put an X here because I need to remember something. And it even tells us because it has an X in it, and that's how I always remember it. Reflexive property. That means anything is congruent to itself. So Ms. Dubois is congruent to Ms. Dubois. Let's see here. And now that we have this all labeled out, what kind of proof is this? This is side, side, side. And you know that because none of the angles are taken care of. Now that we have a rough idea of what these are going to look like, these are the two most common flavors. If there's a third one, I didn't see it when I was doing the screen grabs. And now we're going to look over here, and gee, that looks suspiciously like the diagrams up here. Funny that. So we start this one for introduction. You're writing the proof from scratch. And again, love-hate relationship with the software. So you're going to start with your given. So DE is congruent to FG. That's given. And DE is congruent to FG. Okay, next up. Angle EDF is congruent to angle GFD. Again, that's given. EDF is congruent to GFD. GFD, this angle right there. Okay? Next up, gee, what do I do? Your brain is starting to skitter to a halt and you're thinking, wait a second. This is either side, side, side or side, angle, side. Now, it can't be side, side, side because we have an angle in here, which means this is side, angle, side. Oh, wait, I know this because we did this over here. Okay, so that means that DF is congruent to DF. And what was the reason for that again? The reflexive property. Reflexive property. And do we have everything we need? Do we have a side, an angle, and a side? Yes, we do. So now we're ready. Triangle DEF is congruent to triangle FGD because of side, angle, side. That's what they're setting you up for. This one is a bow tie theorem, which means it's the exact same setup as this one over here. So we're going to start with our givens. So we're told that ST is congruent to T or UT. ST is congruent to UT, and that's given. Next, we are told that RT is congruent to VT. That is given. And which one is that? RT and VT. There we go. Next up, gee, what do we do? It's not like we haven't done this before already a couple of times. So what is it going to be? Oh yeah, we have some vertical angles here. So let's make sure I name this right. So it's angle STR is congruent to angle STR. So UTV. And that's because of the vertical angle property. Vertical angles are always congruent. And now we're ready. Do we have side angle, side, side angle, side? Yes, we do. So triangle RST is congruent to triangle VUT because of side, angle, side. Okay, we're starting to get the hang of this. I'm starting to feel confident. Now again, the software, because you actually have to input these lines, the typing can get a little obnoxious after a while, but the setup itself, these proofs are very deliberately done in only about 3 to 4, maybe 5 lines, okay? Now, get a little bit more complicated, but again, we know it's either going to be angle, side, angle, or angle, angle, side. And so long as we label everything, we'll be all set. So what do we know? ABC is a right angle. We know DEC is a right angle. And again, I can't say this enough. Label everything. For the sake of your sanity, label everything. What else are we told? We're told that BC is congruent to EC. Oh, and then we have, I can take a guess. Okay, so they set things up a little bit differently here because they didn't actually say that your angles are going to be congruent. They just said that they're both right angles. But there is a thing in geometry that says all right angles are congruent. So angle ABC is congruent to angle what? Angle DEC. Okay, so far so good. BC and EC, that was given to us. So what we're doing is we're checking off boxes. So there's our angle. There's our side, and now we need an angle. ACB. ACB is congruent to DCE. DCE, so those two angles are congruent. Gee, what kind of angles are those? Oh yeah, they're vertical angles, and they have a property that says that they're always going to be congruent. And what kind of triangle is this? Let me pull this out because the doodles look a little bit sloppy. We have an angle, we have a side, and we have an angle. So this is going to be angle, side, angle because the side is between. All right, next up, right angle, right angle. So PRQ, PRQ, there are my right angles. So why do we know that? Well, we were already told all right angles are congruent. And you're starting to see Ms. Dubois starting to shorthand here. So angle PQQ, PRQ, no, angle PQR. PQR is congruent to angle PSR because that was given to us. And then they tell us outright, reflexive property, so PR is congruent to PR. Then now we're ready. If we pull out this triangle, what do we have? We have an angle, but the side isn't between, it's all the way over there. So that is angle, angle, side. So that's everything for now for geometry goal 3, congruence and proofs. Next video, I'll talk about the last 3 and Ms. Dubois' favorite thing to say ever, CPCTC. As always, stay happy, stay healthy, stay safe. We'll see you in the next one.